Hey there, this is an introduction to WebSockets. This presentation was made for a Sheridan Interactive Media Management program course that I'm taking. So first off, what is a WebSocket? It's a communication protocol that's used to send and receive data on the internet, quite like HTTP, but WebSockets are way more efficient, and I'll get into that later. They also allow for persistent two-way connections, which make it very easy to build real-time applications like Facebook's chat application pictured in the bottom right. So let's contrast HTTP and WebSockets. So HTTP, the technical term is half duplex, which means it can only go one direction at a time. The data can only go one direction at a time. Whereas with WebSockets, it's full duplex, and the data can flow freely back and forth between the server and the client. It's analogous to HTTP being like walkie-talkies, where you have to say, over and out when you're done your message so that the other side knows that they can start sending their message. And then WebSockets are like having a phone call where both sides can be talking at the same time, and there can be even more than just two parties involved. Continuing the contrast between HTTP and WebSockets, we see that on HTTP, the connection usually closes after the request and response pair, but it stays open on the WebSockets. You have the request and responses on HTTP, whereas on WebSockets, it's more about emitting and listening to events. And on that note of kind of like a syntax differences, with HTTP, you're familiar with the HTTP and HTTPS that you'll see at the beginning of your URL. With WebSockets, you'll see WS and WSS. Next, you see that there are headers in HTTP, and each header is quite large relative to the frames that are used on WebSockets. So it's a very large difference here. There's also about 3 times more time required to create a TCP connection for each HTTP message, whereas it's only 50 milliseconds on the WebSocket. There's polling overhead on HTTP because they're constantly asking if there's new data available because the server is not going to proactively send it out necessarily. So the client has to constantly check if if anything has changed. And this means that there's a lot of messages sent that are not that do not carry any data. They're just checking to see if new data is available, and this is wasteful. Whereas on WebSockets, there isn't this polling overhead, and the sockets only send messages when there's data to be sent. So how do these WebSockets actually work? First, you have the client sending a regular HTTP GET request to a URL. In my example that I'll show you soon, it's to this Heroku server where my app is hosted. Next, the server responds with the requested files, which include some information for connecting to the socket server. In my case, I'm using Socket.io, and there is a Socket.io client JavaScript file that's sent back to from the server to the client, and this kind of informs the client that the server may be able to support WebSockets. So in the next round of communication, the client sends an HTTP GET request with a connection upgrade in the header, which means it wants the server to upgrade their connection from HTTP to WebSockets. The server then confirms that it can support WebSockets, and the connection is upgraded. This step is called the handshake, and this connection will persist until one side disconnects. So is there anything bad about the WebSockets? Not much, but there isn't complete compatibility across all browsers. Not all browsers support it, and different browsers support WebSockets differently. So as you can see below from caniuse.com, there's the first browser to support it was Chrome back in March 2016, and as of last week, most major browsers, the most recent version of them, support WebSockets, except for Opera Mini, but older browsers, many of them do not. So to resolve that issue, Socket.io was developed. Essentially, it's two JavaScript libraries, one for the client to use on the front end and one for the server to use on the back end. It makes use of Node.js. And the cross-browser compatibility issue is addressed by using fallbacks, where Socket.io will select the best protocol to use based on the user's browser. So that may be WebSockets if it's supported. If it's not supported, then it may use Comet, Flash, or another alternative protocol. So here's just a little sample of some of the code required to set up a socket server. In the yellow box, I'm creating an HTTP server, and in the green box, I'm telling Socket.io to listen on that server for any incoming events and connections. More code from the server side. You'll see that there's a lot of listening events where you see the .on. So in that first box that's yellow, you'll see it's a connection event that we're waiting on, and as soon as we hear the connection event, the callback function is called, and that socket is passed into that callback function. And within the callback, we're adding that socket to an array called connections, and we can do whatever we want inside this callback. In this example, we're emitting a custom event called update students with a payload that means that's the data that will now be sent back to the broadcasted to all sockets, because this emit event is an io.sockets.emit event. Below the second green box, you see it's a this.emit, and that would be sending the message just to the socket, the client socket that has the that would be referred to as this in the case here. Now Socket.io has code on the client that's running. At the beginning, it's just some setup that creates the initial connection. So you'll see that I'm adding Socket.io and telling it to poll or to send a GET request to a particular URL and port. So this is just local testing, and you see localhost on port 3000. The client side has very similar syntax to the server side. You'll see that there's listening.on events, so listening for a connection event, a connect event. That would then trigger a callback function where you can perform some calculations or manipulate the data in any way, and then if you so choose, you can then emit an event back to the server, and in this case we're emitting a custom join event with a payload of new student. Alright, so now I'll show you a demo that I've put together following the alinda.com tutorial, and essentially the demo is for presenters to poll their audiences. So let's switch over now to Chrome where I can show you the demo. Alright, so I've created a number of windows here so that I can demonstrate how there is real-time communication between the server and the client. So this represents 4 clients. They could be on mobile devices or on computers, all connected to this application. The first tab I have open here is for the speaker, the person running the presentation. So I'll just put myself there and say start the presentation. You'll notice that the other tabs all had my name appear. So I'll add people to the others. You can just add some names. These are students or audience members who will be watching the presentation and waiting to answer questions. So I can see that there's Alicia, Greg, and Sally who are my attendees, and I have pre-populated the application with some questions related to my presentation. So if I ask them what is a WebSocket, immediately you'll see their options available here. So Alicia wasn't paying attention and she thinks that WebSockets are what plugs your toaster into the Internet of Things. Greg was paying attention and knows it's a communication protocol. Sally also knows it's a communication protocol. Now, you're able to see the results here. It's a little bit distorted because of the size of my window, but it just graphs out the results that we saw. I'm just going to head back to the question. Now I'm going to do it one more time and show you the graph as people are answering questions. And so let's send out this question. So what's wrong with the WebSockets? Once again, Sally's not paying attention. She thinks they're too fast for humans. If we go over to the results now, I can continue to answer over here. And as you see, Alicia's graph is updating in real time. Also, this application is set up so that if you leave, like you're disconnected, it'll automatically reconnect you if you had previously been logged in. And this is done using session storage. So the same goes for the presenter. The presenter leaves, it reconnects you there. There's a little bit of a delay there, but it's working. Now, if you'd like to test the code yourself, I've uploaded it to GitHub, and it's heavily commented. So you can see just some examples here. There's a lot of comments in here explaining every single step. I learned how to put this together by watching the alinda.com tutorial, and I paid very close attention and made a lot of notes. So if you're someone who can learn by reading text easily, if that's better than watching a video, then this will be very helpful for you. I would recommend starting with the app server JS file, then starting with, that's in the root folder, then going to this app.js file that you'll find inside of components. And then from there, I would go to the other components. These are React components, and look at what each component is doing, and then look at the individual parts that are used in those components to understand how this application all ties together. It's not just WebSockets used here, there's React and a few other technologies. So that's the end of the presentation, and if you'd like a copy of it, I've uploaded it to SlideShare here. Thanks for your time.